in human factors and ergonomics at the University of Minnesota, working in the Wearable Technologies lab. His research interest includes soft robotic haptic system on the body.
Yeah, hi. So thank you for the introduction. And yes, I'm Robert Pettis-Baker. I'm here to present our work on Robo-Coverstitches. And you may notice we are the actuator that snuck into the sensing section, but I'm very happy to be here. A bit of a quick background. So developing actuators that are low profile, comfortable, and readily producible is a big challenge for soft robotics. Especially when we're trying to mimic traditional apparel forms. Previous work from our lab has shown that cover stitches can be turned into soft sensors by basically introducing a conductive thread to create a stretch sensor. We also know shape memory alloys, aka SMA, can be stitched, and so as of now, or as far as we are aware, SMA hadn't been stitched using a cover stitch, so through the powers combined, we created our Robo-Coverstitch. So for those of you who don't even know what a cover stitch is, you've probably seen one before because I guarantee you own a piece of clothing with it, but it is made from 3 to 5 threads that loop together to create an extensible stitch. The diagram is one example of a cover stitch. And so to create one of our Robo-Coverstitches, you replace one or more of these threads with SMA, as long as it's the same size as the thread. For this initial study, we chose to do a 3-thread combination, so the 2 needle threads being non-active material and then the bottom looper being SMA, because this is one of the most common cover stitches you see. If any of you are wearing a t-shirt right now, your hem on your shirt is probably a 3-thread cover stitch. So for this, we use 70C Flexanol wire in a very thin diameter. Of course, we want to mimic the size of normal thread in the looper. And then Kevlar thread was chosen as the inactive threads because it can, 1, hold up to the strength of repeated actuation, but 2, SMA do heat up when active, and so we want to not burn through our other threads. Everything was sewn on a scuba knit fabric. So we made 3 samples. First was a single cover stitch just straight down the line. A second was 2 cover stitches next to each other. And then finally 2 cover stitches next to each other with a slit on the middle. Basically we want to just see if there's any interference with them being next to each other. And everything was tested using an Instron tensile testing machine. So we placed samples in the Instron both with the lengthwise and widthwise, the stitch lengthwise and widthwise relative to the clamps, with the exception of the one with the slit, just because you can't really stretch it. But they were strained at from 0 to 15% with 5 testing cycles per strain. We powered each sample to 0.4 amps for 2 minutes. Here you can see basically an example testing cycle. You'll notice that the first cycle is obviously very different. We think that's just because as we switched between strain percentages, it needed sort of 1 round to kind of relax into a more regular form. So we did eliminate that from the final analysis just since it's so different from the rest of them. But it is good to know for future applications. So I'll refer you to our paper for the full results, but the main things are 1, as you might expect, if we have those 2 actuators instead of 1 actuator, the force does increase, which was pretty expected, but more importantly, between inactive forces and active forces for both the length and widthwise directions, we see an increase in force, suggesting we have auxetic properties, meaning we're getting contraction of the actuators in all directions, which is very, very interesting for potential applications. So to basically quickly wrap up, Robo-Coverstitches can be easily incorporated into textiles using traditional manufacturing methods, a common cover stitch machine without any major modifications to the machine. The auxetic behavior of the Robo-Coverstitches has a lot of interesting possibilities, such as selective stiffening, and our future work is hoping to test more different versions of the Robo-Coverstitch, testing on, of course, different textiles, and then obviously pursuing applications. So thank our funding source, and then also thank our previous presenter whose previous work greatly inspired this project. Thank you.
Thank you for a great presentation. Okay, so let's take one quick question, and then in the meantime, let's switch the laptop.